and welcome to space, here from the Observatory of Paris, where we're taking a close look at our planetary neighbour, Venus. A strange world where the sun rises in the west and sets in the east, and a day lasts longer than a year. But first, let's have a look at some more news from the universe this month. Two probes have just reached Mars, NASA's MAVEN spacecraft, which will study the atmosphere, and India's Mars orbiter mission. This is a new 16-lens telescope conceived by a consortium from Poland, Italy and Romania. It will spot previously unknown asteroids close to Earth. And ESA's astronaut Alexander Gerst has been developing new vaccines on the ISS by examining how salmonella microbes become more virulent in microgravity. And now to Venus, a planet which has entranced scientists for centuries. Founded back in 1667, the Observatory of Paris has seen all manner of new ways to study the solar system, including a raft of devices to watch Venus pass in front of the sun.
Ici, nous avons un exemplaire unique.
This is a unique example of Jansen's revolver. This instrument was designed at the Observatory of Paris to observe the transit of Venus in 1874 and 1882.
Today, the Observatory of Paris remains at the cutting edge of planetary science, and it's home to Thomas Wiedemann, a specialist who spends his time trying to solve the puzzle of the planet Venus.
Venus and
Earth are like sister planets. They were formed in the same part of the solar system, even closer than Earth and Mars are, with the same basic ingredients, the same gases, the same rocks that were spinning around the early solar system. And yet these two planets had completely different destinies.
So Venus began more or less like Earth, but now it's bone dry and cloaked in a thick, choking atmosphere of sulfuric acid and CO2.
It has a very dense atmosphere, to 97% of carbon dioxide, a very strong greenhouse effect, and the temperature down on the surface is more than 450 degrees Celsius. And the surface pressure is 92 bars. It's almost 100 times more than the Earth. So it's a very, very unpleasant place to be.
Unpleasant and also unusual. This is the only planet which rotates clockwise, and there's more.
Venus is the only planet in the solar system that needs more time to rotate once around its own axis than it rotates around the Sun. So it's 243 days for one Venus day, and it's 224 days for one rotation around the Sun.
In 2005, ESA launched the Venus Express spacecraft to have a closer look at this oddball planet. After 8 years of scanning the dense clouds below, the team sent Venus Express skimming into the top layer of the atmosphere, a technique known as aerobraking. Don Merritt from ESA's base near Madrid explains.
We went into the atmosphere in this direction because this face of the spacecraft, which had been attached to the rocket originally when it was launched, was most able to take the forces and the temperatures. We also turned the solar panels to maximize the amount of friction and to get the most amount of braking in this kind of gold foil.
The aerobraking maneuver offered the first ever close-up view of Venus's upper atmosphere, and it wasn't what was expected.
What we saw that was a little unusual is the variability in the pressure, as if there were waves within the atmosphere. And so that possible wave-like structure was not expected. And analyzing that data will keep scientists busy for a little while yet.
The science team has another puzzle from the Venus Express data. They've noticed that the Venusian winds are getting faster.
When we arrived at Venus 8 years ago, we detected winds at 300 kilometers per hour, very fast. But what has happened during these years, until now, they have actually increased. We now see winds of 400 kilometers per hour. And we can't really explain why that has happened.
Yet more riddles lie in the landscape of the planet. One of the very few photographs of the surface of Venus taken by Russian probe Venera 13 shows no sign of volcanoes, but plenty of volcanic rock.
La surface de Vénus est relativement
The surface of
jeune
Venus
à
is
l'échelle
relatively
de
young
l'histoire du
on the
système
scale of the
solaire.
solar system.
Et il y a une contradiction
And there's a
pour
contradiction
nous
for us between the
entre
absence of volcanic
l'absence
and
d'activité
tectonic
volcanique
activity
ou
today
tectonique d'aujourd'hui
and this
et cette
surface, which,
surface qui,
despite
malgré
everything,
tout, paraît
appears quite
relativement
young.
jeune. Donc il existe peut-être des processus
So maybe
géologiques
there are some rare,
très rares,
powerful and violent
très puissants,
geological
très violents,
processes
qui pourraient
that could resurface the
finalement avoir un
planet in a
rôle de
catastrophic way,
resurfaçage,
creating a
une forme
kind of
absolument
rebirth of the Venusian
catastrophique,
crust.
une sorte de nouvelle naissance pour la croûte vénusienne.
About 243 days.
So, what could possibly have happened to Venus to turn it into such a hellish place? There are some theories, if not yet proof.
Is a mystery. There must have been a major disaster in the early history of the planet where it collided with a big other object. And this made it stop its rotation. And I think this was really the turning point in the life of Venus.
Clues as to what happened in the past may yet be found in the vast amounts of data gathered by Venus Express, and Venus itself will continue to entrance and surprise.
Vénus est la planète la plus brillante du ciel.
Venus is the brightest
Et
planet
c'est
in
le
the sky.
luminaire le plus brillant
It's the
après
brightest
le
light
Soleil et
after
la
the
Lune.
sun and the moon.
C'est une planète qui fait partie du patrimoine
It's a planet that's
culturel
part of our
humain.
cultural
Et donc, c'est cette,
heritage. So it's this
personnalité
special
particulière de Vénus
personality of
comme objet
Venus
brillant,
as a shining
culturel,
cultural
qui m'attire
object that
finalement le
attracts me the
plus.
most. Maybe
Plus encore
even more
peut-être que
than
les
the
raisons
scientific
scientifiques
reasons
que
we've
nous
talked
avons
about.
While one spacecraft has a close encounter with Venus, another, Rosetta, is having an even closer encounter with a comet. Let's see how the team are getting on. Now that Rosetta is at the comet, all eyes are on Philae, the lander, which will touch down on the comet's surface in November. Here at ESA's Astronomy Centre near Madrid, Larry and Michael manage which instruments do what and when.
Well, I've seen something on the elevation camera. The tricky bits are the unknowns, of course. Every day it's an object which is coming alive. Every day it's producing more gas, more dust.
The landing site has now been selected, and of course we all hope that it will be successful, and it is clear that it is a risky business, but I think it will be a success.
The landing itself is a huge event. We separate the lander at a certain distance where it says bye-bye to the mothercraft, which has brought it so far. And within about an hour or so, it starts uplinking the images. So, of course, getting the signal from the lander will be very important. Hey, Rosetta, you may be hundreds of millions of kilometers from here, but don't worry, you're not going to crash into the comet because we know exactly where you're going to go. Keep working, keep alive, and keep sending those beautiful data to us, beautiful images.
Rosetta, well, it was a long journey, but now you are there. I trust in you. We will have a great journey till the end of the mission.
That's it for now. Next month, we'll have an insight into one of the trickiest aspects of spaceflight, re-entry. See you then.